And today in our video, we will talk about alternative energy sources. And of course, when you talk about alternative energy sources, one of the first things you come to mind is nuclear power. Now, in nuclear power, there's a lot of plus and minus, and we're going to look at a couple videos to explain what that is. So just a brief introduction. And we know that it's a non-renewable resources because we need to use the uranium to make the whole thing work. So in here, the uranium actually takes a long time to refine and actually make into something that you can use. And you have to be careful because as a byproduct, at the end of the cycle of the nuclear power plant, they will have the uranium waste. And that could turn into dirty bombs. Basically, it's atomic bombs in the less destructive manner, but actually it's still a pretty bad radioactive contamination. And in here, in Hong Kong, we use 25% of the electricity from here, the nuclear power plant, which is not that far away from Hong Kong, as I have shown some of the classes in the map. And it's around 25 kilometers to 30 kilometers away from Hong Kong. So in here, how does it produce electricity for Hong Kong? Let's take a look. This one, I need to show you this. Then nuclear fuels will undergo reactions to release heat. After it's heated up, the heat energy will boil the water into steam and it pushes a turbine to produce electricity. So from that, let's take a look at some of the advantage and disadvantage. Okay, so in here, the advantage is a small amount of nuclear fuels can be used to generate a large amount of electricity, which is a good thing. But on the downside is that the nuclear fuel supply is limited, and the nuclear fuels and the waste byproduct in the nuclear power plant stations are highly dangerous. And in the world right now, only one country has the capacity to manage this kind of waste. It's actually not US, but in France. It is what they do as an industry. People would be shipping a lot of this nuclear waste to them, and they would manage it and make it more sustainable, I would say. Okay, so now let's take a look at some of the videos I prepared, and in today's lesson we have almost 10 videos, so you have to be patient, okay? So in here, that's the first one, and it explains what is nuclear energy. so this is the simplest video on how nuclear energy works. And in here, there's one word, it's called chain reaction. Some of you might have heard of it before. And this chain reaction means that when you started and when something is in motion, when you started in one object, it will lead to other things that comes along. So basically it's a metaphor as well. But in here, it actually have a literal meaning, meaning that all of it will start at one place and then lead to the second splitting of the atoms and lead to the third one, fourth one, and so on. So basically it's a chain reaction that keep on going for thousands and thousands of years. And in here, because of this chain reaction, it will lead to this heat being generated, and we transfer this heat into the boiler as again it boils the water and it pushes the turbine, and the turbine will drive the generators to produce electricity. So basically that is the overall process. Okay, so it's the easiest explanation that I can find to explain to you what that is. Now, as in this video, it mentioned about some of the toxic material that is the radioactive waste and the pilots like that. And in history, we human beings have done a lot of things. One of it is Chernobyl. And some of you might have heard of before, but this is already 30 years ago. And there was an accident and the nuclear power plants exploded. And so now it's 30 years later. Let's take a look at it.
The large reason why these animals seem to be persisting in high densities or a high abundance within the exclusion zone is because of the absence of humans. As you drive around the exclusion zone, you're overcome by all the lush nature. It's really an eerie reminder of the tragic human impact that occurred there back around 30 years ago. The Chernobyl exclusion zone is basically a 30-kilometer radius that was created that extends around the nuclear reactor where the accident occurred. And within that 30-kilometer zone, that's where preventative measures were taken to exclude people. So all the towns, villages, cities within that area, that 30-kilometer area, were evacuated.
Years after the accident, this woodlands increased up to 1.5 or more times. So now approximately 70% of area under the forest.
If we talk about large mammals like carnivores and ungulates, it's really good habitat because it's a wild territory now, and especially this very wild spot along the border with Belarus, and also many different water sources like lakes and rivers and springs.
Okay, so you can see that after 30 years, human beings cannot live there anymore, and yet you will see that there are all kinds of animals is moving into this area. And let me see if we can find that. Okay, so you see there's all kinds of animals living in that area. Now, human beings are discouraged from living in there. There are people who actually still live there because they're too poor to move away, or really old, they don't want to move away. Some people are still actually living in that area, even though it should be prohibited. And yet, in here, animals will move in because of the lack of human beings. It's kind of like a reserve. That's why the animals want to move back in there. But whatever they do there, they're still highly radioactive. The ground, the water, and everything. And of course, if you mention Chernobyl, some of you might not have heard of this one, the 3 Mile Island. Actually, there's a really famous accident. And from this accident, actually a movie is being made. Well, it's 3 Mile Island as well, but there's another one is more famous. And at the end, after this video, I'll tell you what that is.
It was the first step in a nuclear nightmare. As far as we know at this hour, no worse than that. But But a government official said that a breakdown in an atomic power plant in Pennsylvania today is probably the worst nuclear reactor accident to date. There was no apparent serious contamination of workers, but a nuclear safety group said that radiation inside the plant is at 8 times the deadly level, so strong that after passing through a 3-foot thick concrete wall, it can be measured a mile away. Gary Shepard reports from Harrisburg.
The accident occurred here at the 3 Mile Island nuclear power plant a dozen miles south of Harrisburg. At about 4 o'clock this morning, 2 water pumps that help cool reactor number 2 shut down. Officials say some 50 to 60,000 gallons of radioactive water escaped into the reactor building, and that the radioactivity penetrated the plant's walls. Steam escaped into the atmosphere, and radiation was detected as far as a mile away. At least 50 workers, and perhaps twice that number, were at the plant when the accident occurred. A spokesman admitted that some were exposed to radioactivity and may have been contaminated, but he claimed no one was injured. All workers were given extensive checks with Geiger counters as they left the plant. Reporters were not permitted inside the facility today, but this is what reactor number 2's control room looked like last September when it was still undergoing testing. It went into commercial service only 3 months ago. Officials from Metropolitan Edison Company, which operates the plant, attempted to minimize the seriousness of the accident, saying the public was never in danger.
We may have some minor fuel damage, but we don't believe at this point that it's extensive. The radiation levels at the site boundary are really only a tenth of the general emergency level where we normally get concerned. We do have our crews out. We're monitoring for airborne contamination. The amount that we found is minimal. Very small traces of radioactivity have been released from the plant.
But the company's statements have not answered several important questions. How much radioactivity has already escaped from the plant? How high is the radiation level inside the plant? And is there still a high level of radioactive steam inside?
Okay, so from here, then I'm going to tell you what, after this, people actually make a movie. Besides the 3 Mile Island accident movie, they come up with another one. Some of you might have seen it as well. It's Godzilla. Because they have seen some of the leashes and they turn into a big monster. And I'm not going to show you the movie, but just letting you know that Godzilla is what they come up with after that. So the people are really afraid of the radiation, as they should be, and they start to make a movie out of that. So people start to realize that that could be bad. And of course, the latest one is in Japan, returning to Fukushima.
Nuclear power has been a reliable source of energy for 70 years.
This is too long.
But
I will skip it all the way to around here.
Fukushima Prefecture. When it blew, it spewed radiation across dozens of towns, triggering a 12-mile evacuation zone that's still partially in effect today. The plant itself is still the most hazardous site. If Japan is encouraging people to move back, how have conditions improved in the 7 years since the disaster? I'm meeting up with radiation researcher Asby Brown, who was able to get special access to take us to the plant.
Let's head out.
Okay, so let me
this is an
skip it a little bit more to the site.
Again to live. For 7 years, workers have been moving inch by inch, town by town, digging out layers of poisonous waste, dropping it into plastic bags, and storing it at temporary sites.
These are all bags with the nuclear waste. I mean, it looks like hundreds of thousands of bags just on this one site.
In a second.
In parking lots, fields, and abandoned yards, throughout Fukushima, there are 9 million bags of waste and counting. Japan says the cleanup effort is working, and towns on the edge of the evacuation zone are safe to resettle. In 2015, they deemed Naraha, 12 miles south of the reactor site, the first town ready to reopen. Yet less than half of the 7,400 residents returned.
Mariana, you have a beautiful house. How long have you lived here for? Wow.
About a year and a half after Naraha reopened, the government cut off subsidies paying for evacuees to live in temporary housing. They hoped residents would come home, but many chose to move elsewhere.
Oh, wow.
And although the government claims the land is safe, Yanai is not convinced. So he's willing to put his life in danger to clean up his place.
Most of the places around here, it's the government workers that are removing the contaminated soil, but you've decided to do it yourself. Why?
期間でやってますから、完璧なんだ女性はやんないですね。
How much time did that take you?
3年くらいかかってますね。
Can you show me how you do it?
The top layer is all toxic soil. So in order to decontaminate it, you really have to excavate.
海近い、山近い、観光の客もね、結構来られてた。7年が過ぎましたね。この放射能で制限された生活。諦めないね。この自分の家を守んなくちゃなんで、この街をね。
It's not just fear of radiation preventing residents from returning to Naraha.
Konnichiwa.
Hello.
After years of abandonment, towns in the area have been overrun by wild boars. They're ravaging homes and everything in their path.
農作物とかいろいろ作っても全部イノシシに食べられちゃうから、そのためのイノシシを農家はこれから先慣れたじゃない。
The boars are not only aggressive and known to attack, they're radioactive.
生活環境を良くするためなんですよね。
How many boars have you caught this way?
今までで2000頭くらい。
2,000 hogs?
はい。でもまだいることはいりますよね。
So when the boar comes in, he triggers the wire and the gates close.
Whoa, yes.
これからね、いや少し急いでるの。急いでもうイノシシすでに取って。
So you're saying we have to go because they think they've caught another boar in one of the other traps and they want to go check it right now? It's dangerous?
危ないです。
They attack you?
すぐ戻ってきます。
I think it's right there. Being held by something around his foot.
あまり近くまで行かないで。もちろん離れたらかかってきますよ。
It's a big one.
今もう完全に興奮して今怒ってるとこだから。
Okay, so this one is a radioactive hawk, basically radioactive pig that is living around Japan right now in the Fukushimas. So in here you have to be careful. Even with the wildlife, they are radioactive. The part that they bite you, yeah, it's bad. But once they bite you, they get the radioactive materials into you. That's even worse. Okay. So in here, let's talk about what they were doing here. They're trying to remove the topsoil from around the farmland. So you see here, they just remove the topsoil and put it in. But there's a problem, as you can tell, by all this effort with the machines and people moving it around. Okay, let me see if I can, yep, stop here. So you see people walking around and then machines are walking around. They will stir up dust, the radioactive dust they're trying to remove. So what they're doing actually is not that effective. As it's proven in the US, they have done a study with this already, but apparently it's not much use. But Japan, because they don't have enough farming land, they have to do it some way to make it more feasible for the people to live on. So that's what one method they come up with. Okay, now, so let's go back to the PowerPoint before I can show you any more videos. Okay, so let's PowerPoint first. Now in here, that's the first thing we talk about is the nuclear power. Okay, so some of the advantage and disadvantage we come up with. Now, the next one we have is some of this We'll go through this one by one. The first one is the solar energy. So in here, all these are renewable energy source, meaning that they can be renewed, and as for the sun, tomorrow you still have the sun there. So in here, the solar energy can be useful. And in here, we got the solar collectors to heat up the water, and also the solar panels. And in Hong Kong, actually, we are only starting to use more solar panels. But even in mainland China, they have the solar power panel already. And even in Australia, there are a lot of power plants with the solar panels already. And in here, Hong Kong in the recent years are starting a program to ask people to install solar panels in their homes. For example, a little townhouse they have, and they would ask them to put the solar panels on top to generate a little bit of power for their house. Actually, it's a good idea because all over US and Canada, people are doing that. And they find out that they actually generate quite a lot of electricity, not only for their own house, but the excess. The one that they don't need, they will also generate that power for the power plant company. So in that case, the power plant would actually pay the residents money to actually buy their power. So it's actually a win-win situation for not only the residents, but also for the big companies as well. So in here, let me show you the advantage and disadvantage. So in here, it can be replenished in a short period of time, that's a good thing, and produce less pollution than the non-renewable energy sources. But the limitation, the sunlight, the duration of it, the light intensity as well, and also the specialized equipment, the solar panels, they need to connect the solar weights. Those are improving the efficiency. And last chapter, we have mentioned about how we can calculate the efficiency. And in here, the solar panels, everything is based on efficiency. The more efficient that is, the more power it can get. So that is one of the ideas that we have learned and actually applying to what the industry are using today. And our next one is wind power. So before that, let me show you one more videos on the solar panel first, and then okay, there's 3 videos on the solar panels. The first one is in Peru. If you remember, that place is really poor. People don't have that much.
This is
money.
Namora, a remote community high in Peru's northern Andes, where farmers spend their days attending to their potato crops under the bright blue sky. People here used to rely on candles for a bit of light after dark, when temperatures can drop to near freezing. But a few months ago, solar panels were installed on their small adobe homes, providing enough electricity for a few light bulbs, a cell phone charger, a radio, and a television. The switch has brought big social and economic benefits. President Ollantaytamala's government says the energy revolution taking place here is just the beginning. In November, the government awarded a 15-year contract to install and maintain 500,000 panels throughout the highlands and the Amazon rainforest. Officials say the project is key to closing the electrification gap in Peru, where it has been too costly to expand conventional power lines despite years of strong economic growth. But completing it won't be easy. Some energy experts are already saying it is too ambitious, pointing to the difficulties of providing maintenance in communities scattered throughout Peru's vast countryside. They also say that convincing villagers that have long been distrustful of the central government to sign up for the program will take time, and this could delay its completion. In Namora, some families were initially skeptical of solar.
Some people didn't want it, because they thought it would be a sham for the community. But it was completed, and now things are very different, and they're very happy with the panels.
Okay, so that is one part of Peru that is happening. And let's take a look at the second part in Bolivia. And over there is a lot of sunshine, but not enough resources. So they are poor community as well. So let's take a look at what they're doing, improving with the solar panel.
Es que este lugarcito es muy amplio y también hay totales para mis ganados, por eso vivo aquí. De noche no tenemos, con velita vivimos aquí. Con velita no siempre vivimos, de noche también a veces no hay velas, con mecheritas.
Kerosene is very smelly.
Llegando
Toxic
de los
waste.
ganados,
Smelling.
nos cocinamos con velita siempre, ¿no? Entonces es así, entonces nos dormimos. Queremos hacer, a veces queremos instalar tele también.
Ahora más bien tenemos panel, ya tenemos los sitios con la luz de cocinar aparte. En la noche nos lavamos también la ropa. Con la luz me siento más segura, más tranquila, ¿no?
Nos dijeron que no va a poder llegar hasta ahí, entonces recomendaron que se solicite el uso de paneles solares, ¿no? Entonces eso no necesita la red, solamente ver, digamos, algunos lugares poco alejados y se puede instalar, ¿no?
Este panel mucho ha costado, pero nos ha ayudado alcaldía.
Todo se puede hacer. Sí, el queso también más sale, igual se puede hacer también. Así yo también, hay veces en el día, hay veces en la noche, igual hago yo.
Panel solar está bien, pues, limpio. Y no termina también pues, su energía, falta nomás.
Para hacer sus tareas, para leer, para escuchar también la tele, bien, más no, para ver también las noticias, para informarse qué es lo que está pasando en otros países, ¿no?
Okay, so in this video, you see that the students need to work on their homework. They can watch TV and they can do a lot of things at night because of this light bulb and the solar panels they install. Without these solar panels, they cannot do anything. So at night, what can they do? They go to sleep, basically, that's it. They don't have power to do anything else. Okay, so that is what's happening in South America. And in here, let's take a look at it, what they are trying to promote in North America, in Canada and in US. In this case, Quebec is in Canada. They want to do this.
Generally speaking, Hydro-Quebec's hydropower generating stations and grid supply the homes and businesses in a neighborhood. A microgrid can be set up by adding technologies such as solar panels, large capacity batteries, and electric vehicles. Connected devices manage home electricity use. Microgrid technologies can supply homes and businesses in parallel with the Hydro-Quebec grid. If the main grid goes out, the microgrid can continue to supply power to homes and businesses for a while, keeping customers comfortable. When the sun is shining and less power is being used, the microgrid can supply the whole neighborhood or part of it. And if the microgrid generates more electricity than the neighborhood needs, the surplus can be fed back into the Hydro-Quebec grid. Microgrids, an energy solution for the future.
Yes, it sounds like a promotion, I know. But in here, if you take a look at this part, if you go back to this part, from the house, the summertime, so in here, during the summertime, a lot of people like to use air conditioning, so it will consume a lot of power. So what happens when you switch off the air conditioning? Those power can be generated for some other business use or some other neighborhoods. So that's why in this commercial, they are trying to introduce the idea of microgrid, the one that you can install a solar panel at your house and then you can generate the power for the whole city. Basically, that's what the whole idea of having a microgrid means. Of course, in Hong Kong, we are just trying to implement it in the last year or two. So you will see that a lot of townhouses, they will start to have this kind of the solar panels on the rooftop. It's because the Hong Kong's company are finally catching up on this idea. The power generated from these solar panels can be sold back to the city. Basically, they buy the supply from your house and they sell it back to the business, charging a lot higher, of course. And in that case, the producer, you can get the money from the company, and the company can get more money from the other big companies as well. So that's the whole idea behind the microgrids. Okay, and the next one we have is the wind power. So let's get this started. So in here, the wind power, of course, as the name suggests, we use the wind. People have been using the wind for the windmills and so on for like thousands of years. This is only one example. Actually, there's a better example that is in Middle East. They have been using that windmill for more than thousands of years. I literally mean that thousands of years. Now, in here, we are starting to use these wind turbines to produce electricity. So in here, you see that on the land, we can do that. And the idea is pretty simple. The wind blows, then the blades will turn, and then in here, the kinetic energy from the wind would be going into the blade. The blade would be actually turned into kinetic energy as well, because it's moving. Again, I mentioned that again. Kinetic energy is something that is moving. You have kinetic energy. That movement would be turned into the generator. When you turn it, what can you produce? Electricity, right? Now in here, the advantage is that it can be replaced in a short period of time because the wind blows and then it will generate kinetic energy already. And it causes less pollution than non-renewable energy sources. Now, however, you have to be aware of that. There are quite a few downsides for the wind power, because if the wind is not strong enough or that day doesn't have any wind, you cannot produce any electricity. And actually, it comes in, you might not realize that, but actually it's really noisy with the wind production. Wind power generator, because when you're turning the turbine, it's moving, they will generate a lot of noise. And the birds are known to be killed by the blade, because the blade is turning and will hit some of the birds, and the birds doesn't know what that is. Well, too bad for the birds. And next one, some people also feel that the wind turbine makes the landscape look unsightly, meaning that they don't like it. Yes, people tend to do the nature thing. They want to see the trees, the mountainside and everything, but not the man-made material like the turbine. So in here, people are starting to come up with the idea of moving it offshore to the sea wind farm. Okay, so in here, let me show you what it looks like first. And in here, actually, I just want to show you some ideas. Then people actually incorporate their ideas. In Bahrain, they actually put the wind turbine between two buildings. And as it turns out, it has a award-winning design. In this case, you see it's a really windy city, and the turbines keep on turning, and it generates the electricity for the buildings itself. So actually it's an interesting design, and unfortunately is that it's kind of dangerous, you know that, and noisy. So people actually not too happy with this design for some people. If you're living next door to it, you can hear it moving all the time. So it's an idea that you can take a look at it, and people have used this idea already. And there are many things you can look into it, but we don't have enough time to explore more. So let's go to the next idea of the hydroelectric power, meaning that using the dams for the electricity generation. So in here, we use this to generate electricity. So let's just have a quick look at the animations. Now, so in here, let's just keep running for a second. So if you take a look at it, that's the design, that's the dam, that's where the water is. Okay, and there's the opening there. And I think I need to just like keep going for a second. Okay, so in here, that's the top view. Oop, don't want that. So you see the turbine here. And the water will go in here and going through this tunnel inside, and then they will turn into, and they will turn the turbines, and the generator goes along with that to generate electricity. Okay, so this one's not that exciting. So let's go back to the one I want to show you first. In Africa, to see what's happening. Actually, in Africa, there is one of the biggest hydro plant on earth. It's even bigger than the one in China, the Three Gorges Dam. This one is huge.
This scene of destitution is a few miles away from Ethiopia's Grand Renaissance Dam. Local people here still live in prehistory, with no running water or electricity or decent homes. They say they are patiently waiting for the benefits of the dam. What patience is there to muster these workers need to finish the mammoth task? They work the night. Daytime shifts are busier as the work progresses.
The project is made up of 3 parts: civil works, which are now 87% complete, the steel works, which are going a bit slow with 17% completed, and the electromechanical works at 35%. And all those 3 components show that the dam is 71.2% complete. We're planning to start filling the reservoir next June and will be able to start producing electricity a year later.
Once finished, these giant tubes will channel the river waters down through turbines 9 and 10, which are still to be placed here. The powerful jets will rotate the turbines, and the hydropower engines linked to them will transform that into electricity. Each turbine will produce 370 megawatts. When all the 13 turbines are completed, the dam will be able to produce a little less than 6,000 megawatts, enough to satisfy Ethiopia's needs and to export electricity to regions as far away as Southern Africa and Western Europe.
As you can see behind me, that middle section hasn't yet been finished. It will require 2 million cubic meters of rolled concrete slabs to raise it to the final height. That's also where the 13 power turbines will be inserted. 2 of them will become operational early next year, and that's when the first hydropower production begins.
Ethiopia says this is crucial for its economic development. Sudan, the passage country, believes it has nothing to fear, despite warnings by some of its senior experts. But Egypt, the river's historic destination, feels threatened. Since the dawn of time, it had the lion's share of the Blue Nile waters. But the desert country described by Herodotus as the gift of the Nile believes the dam may deprive its population of its most vital resource, especially if Ethiopia insists on filling the 74 billion cubic meter reservoir in 3 years. Egypt has suggested it should take no less than 7 years. As the talks in Washington, D.C. stumble at each round, time is of the essence to both nations. Meanwhile, the historic dam continues to take its final shape. For the legendary river, this is a mighty handle that will control every drop of it for the first time in history. A river that flew freely in the wild for millions of years is from now on forced to squeeze its way through these narrow iron frames of brick and mortar. Its future, and perhaps that of the millions of people on its path, is now set in stone for ages to come. Mohammed Val, Al Jazeera, at the Grand Renaissance Dam, Western Ethiopia.
Okay, so in here, that is the Ethiopia's effort to make the dam, to make electricity for them and the nearby countries. And from that, you see that there's a explanation on how it's the opening, the water goes in, and then it will turn the turbine to give the electricity to the people who is waiting for it. So in here, the advantage is that it can be replenished in a short period of time and it produces less pollution than the other non-renewable sources. Of course, there are limitations. The construction of these dams damage the land and the water habitats, meaning the fish. That causes harm to animals and living things nearby. Even people nearby have to move away. That's what we have seen in China already. And the same thing is happening in Africa as well. And in here, we got the fifth one, the biomass. So let's take a look at one quick one on the biomass, what's happening in Singapore. And unfortunately, I can't find one in Singapore, so I have to find one that is organized by a company, Honeywell. I used to work for them. So that is interesting to see what they have come up with.
It starts with Ensign's proprietary RTP technology. RTP is the world's only fast pyrolysis process with proven commercial application. In fact, it's been used for over 20 years in the manufacture of more than 30 different products, including everything from flavorings to adhesives. Here's how the process works. RTP uses non-food cellulosic biomass feedstock, typically from the forest products and agricultural sectors. This feedstock is rapidly heated in the absence of oxygen by a tornado of hot sand. The biomass is vaporized, then cooled, yielding RTP green fuel, all in less than 2 seconds. RTP also yields char and gases which are returned to the unit and used for heat generation, making the process virtually self-sustaining. RTP green fuel can be used immediately.
So because of time, I don't have the time to show you the whole video. If you're interested in, you just search for biomass to renewable fuels. And actually, that's what's happening around the world. People are searching for new ways to improve human lives and generate more electricity. Okay? So in here, that's the biomass, and in here we turn all the plants and animal waste because it's from biology, so it's biomass. And in here, there's examples. That's the biofuels. I showed you the video already. That's one way of producing it. And in here, people use the soybeans and all different kinds of things, any living things that can be turned into biofuels. Be aware of that. It's just how efficient is one compared to the other. Now in here, the limitation is that it can be replenished in a short period of time, and after that, less pollution as before. But in here, it requires a large operation to grow a lot of plants, the agricultural plants, to generate that kind of electricity. So it might not be that effective, you know that. So as long as it's not used properly, the greenhouse gas and the foul gas will be generated as well. People find you don't want that. Okay, so because of time, I will run a bit faster in the next 2 PowerPoint. So in here, so in Hong Kong, we have this virtual park. You can visit that if you have time. And in here is just quick summary of the alternative energy and compared to the fossil fuel. And in here, you need to save energy. I'm not going to spend too much time on this. And I want to skip through the new technology as well. So this, you can go and watch it later. I'm not going to spend time on this one. And I want you to look at the last one, the checkpoint 5.8, the 3 ways you can save energy. So I want to make sure all of you have the answer for that. First one, turn off the electronic appliances when you're not in use, and choose one electronic appliance with grade 1 efficiency, so it saves energy. And the last one, make sure the air conditioning to keep a moderate temperature, so it doesn't need to be running all the time. Okay, so that's the time I have, and make sure you can check out some of the sites I mentioned there in the video already. Okay.